This is a download from BFM 89.9, the business station.
BFM 89.9, the business station. This is the evening edition. And, well, when it comes to natural disasters, landslides have a huge impact on Malaysia in terms of injuries, deaths, property damage, public inconvenience, economic as well as financial damage. But why exactly do landslides happen? And what can we do to prevent them from occurring time and again, or at least mitigate the risks and damages that they cause? Our guest, Datuk Zakaria Muhammad, an engineering geologist and the State Director of the Selangor Minerals and Geoscience Department, is here in the studios to tell us more. Welcome to the show.
Thank you very much.
Yes. Okay, so let's start off with a bit about your work and the work of the department. Tell us a bit about that.
I work with the Department of Mineral and Geoscience Selangor and Wilayah Persekutuan. And I'm a geologist. Our role is to do and carry out the geological mapping and also investigate geohazard and so on. At the same time, also we have a program regarding with the development of resources such as quarries, sand, and so on. Yes.
And who do you typically work closely with? I mean, developers. In what type of industries?
Our industry involves housing, developments, coordinates natural resources, rock and soil and sand and so on. And also we work closely with the state government and local authorities because GMG one of the members of state planning committees. And also we are members of the one-stop center at the local authority levels in order to review in all the development proposals in the state of Selangor. Yes.
And of course, we're here to talk about landslides.
Right.
But of course, within the department in itself, what are the main concerns and challenges? We've just started the year for 2013. Are there things that we want to improve on within the state of Selangor on these areas that you've just talked about?
Oh yes. With regard to the event of natural landslide and also man-made landslide, we need to know more about the subject matters, especially in Selangor. We need to know where is the risk area so that we can manage the risk. That's a very important factor. In order to do that, we need to map out those hilly areas so that we can focus our resource in order to mitigate the risk and to reduce the risk.
And this is what you're referring to in terms of geological mapping and trying to get a better sense of the terrain.
Oh yes, we have a special program. In fact, I am the coordinator of the National Geohazard Studies under Department of Mineral Geoscience, Mineral and Geoscience. We carry out geological terrain mapping for hilly areas. As well, we carry out a geological mapping in order to understand the phenomena of the landslide and landslide prone area. Yes.
You were mentioning before about natural landslides and man-made landslides.
Right.
Can you just tell us a bit more about how we would define these?
When we're referring to the natural landslide, means it occur on the natural terrains. That means untouched ground, because landslide is the movement of the earth or rock or debris downslope. It happens on the natural terrain as well, for hilly area and so on. Whereas man-made induced landslide, that's related to the, for instance, cut and fill slope or excavated ground and so on. Yes.
And of course, typically, some of the events that have been happening, quite recently, is there something that we can learn from some of these experiences to why these landslides occurred and how we would have mitigated it a little bit further?
Well, if you look at the case studies since 1993, Highland Tower tragedies, which killed 48 people. And in fact, I am one of the investigating team at that particular time. And then after that, subsequent that, there's numerous of occurrences or landslide, especially toward the end of the year, in the month of November and December during the heavy rains. For instance, last year was, 2012. In Malaysia we have rainfall in the range of 3,000 to 350 millimeter per year. That's very high.
Yep.
And of course, people thought about the climate change and so on. the intensity of rainfall is increasing with time. For instance, for last year, I got information from the meteorological department saying that for the first 6 months, we only experienced rainfall in the region of half of the 1,400 millimeter per year, whereas another half is occur within three months period. That means the intensity of rainfall is very high. So because of that, maybe certain place, that's why we have experienced the landslide during that particular time.
Our monsoon seasons are becoming more intense,
yes,
and it's resulted in floods in certain areas as well.
Right.
Okay, well, more about landslides after this one. Coming up, we've got Fleetwood Mac Everywhere, BFM 89.9. BFM 89.9, the business station. This is the evening edition, and we're talking about understanding geology and landslides. Now,
my favorite topic, by the way.
Yeah, intriguing.
Thank you very much. It's very good.
Okay, we've got Datuk Zakaria Muhammad, who is an engineering geologist and also the state director of the Selangor Minerals and Geoscience Department. Now, Datuk, last month actually, the front news of our newspapers were full of news reports of soil movement in Setiawangsa. There was landslides. Residents were told to move out. And I think earlier this month also there was one on a construction at the Kingsley Hill housing project that had to be halted temporarily. Now, that's two in the last 2 months. What actually makes Malaysia so susceptible to landslides, and are certain states more susceptible than others?
Like I said before, most of the landslide here is rainfall induced. Mm-hmm. So during that particular times, intensity of rainfall is very high, and then the setting of the ground at that particular site. Usually, we found out based on the case study, numbers of case study phase slope. Those phase slopes, they have a unique features related to geology and also the movement of water and so on. And of course, the loose soil and so on. Based on that, that's why certain place we found out the slope fail induced by the rainfall and so on. That's the reason behind it. It's not all area, but certain particular very unique geological setting in terms of geometry of slope. I mean, very high slope, higher the slope, as steeper the slope, more susceptible to the landslide. That's the situation.
So it's a very dangerous concoction if you have these particular factors, and that sort of increases the chances of a landslide.
Oh yeah, the probability is there, and because the movement of the material is by gravity, the steeper it is, the chances to move down is higher.
And of course, then what do I imagine property developers look to, and how do they mitigate this particular circumstance? Because now, if you have projects being halted temporarily, you can imagine other property developers looking, well, have I fulfilled all certain guidelines, and they're looking over their shoulders. I mean, how do we look at this in a holistic manner so that these incidents occur as less as they can?
So actually, we have very good guidelines in federal, state, as well as local authority and state government. For instance, in Selangor, we have a guideline for the development of hilly areas, and inside the guideline, if you read, is telling the developer and the professionals what to do. They know what to do. So one of the areas is they need to look at is, let's say, if you before you do any earthwork, they have to come up with a plan showing that if you want to cut the slope, you must know how much you want to cut, and in one angle, and then they have to know the property of the materials, and they have to analyze internal stability so that make sure its safety factor is very high, so that the probability of fail is not there. If that criteria fulfilled by the developer, then I think the project shouldn't have any problem.
But these factors you've just mentioned, I mean, they're very detailed, but are they being enforced and implemented as well as they can be, from your knowledge?
Yes, since 2000, after year 2000, then we have at the state level, we have one-stop committees working. I mean, all the professionals from various organizations, from the geologists, from the Department of Mineral Science, and we have also engineers from the Public Works Department. And on top of that, we have consultant engineers outside on behalf of developers work together, and the planners. So with these three group of professionals work together, then I'm sure we can have improved our development process, and we can reduce the probability of failures.
But do we know whether the approval process is almost a case of, once all of these areas have been ticked off, then it's approved, but is there monitoring thereafter to ensure that these measures are carefully implemented?
Yeah, in few cases, we know already, for instance, based on JMG terrain map, we know certain area is... for instance, we have
slightly high risk.
Class 3 and Class 4. We classify the hilly area into class 1, 2, 3, and 4. That means Class 3 and 4, the slope more than 35 degrees and above. When we receive development process of that particular area, usually we focus on that.
Right.
And
so they're given more attention to this Class 3 and Class 4.
Correct. And then also, now we try to impose self-regulation. I mean, developers should have their own team, monitor the works, the contractor works, especially earthwork. That's one of the.
So self-regulation can be a bit dangerous, can it? In terms of because there's a lot of investment involved, a lot of money involved. So surely there has to be a counterbalance to that self-regulation.
I think that is one of the practices right now, not only in other countries, for instance, in Hong Kong and so on.
Sure.
Because they have a professional there. The engineers design or the earthwork plan, and they also make sure that their design followed by the contractor. That's their responsibilities. And then on top of that, on the government side, on the authority side, we also have a check and balance, and we visit the site from time to time. If we respond on any sign of weaknesses, then we ask them to rectify it immediately.
Okay, more about understanding geology and landslides right here on the evening edition after the 7 o'clock news. Taking us there, Cat Stevens with Tea for the Tillerman, BFM 89.9. Good evening, I'm Sonia Zubair.
And I'm Ezra Zaid.
Yes, and this evening we're addressing the topic of understanding geology and landslides. And in the studios with us, Dato' Zakaria Muhammad, an engineering geologist, also the State Director of the Selangor Minerals and Geoscience Department. Now, Dato', in terms of reducing the risk of landslide disaster, has there been enough emphasis on the dangers of landslides and managing those dangers, like flooding, for example?
Yes. When we are talking about the reducing the risk, or managing the risk, first thing we need to do is we should carry out the investigation first, or map out those problematic area. That's the first thing we need to do. Then when it comes to the technology, how we mitigate the risk, there's a two way to do that. One of them is a physical. For instance, we try to improve stabilization of the stability of the slope, the particular area or the risk area. Through, for instance, certain place, that's why you see in Bukit Setiawan's rock anchor, saw nailing, and so on. That's we call it physical. Or certain place, if the slope is very stiff, we try to cut back the slope, make it gentle, so that it's safer. That's one of them. And the most important thing is drainage system must be well in place and functional all the times. That is one of the most important and very cost-effective thing.
That cannot be more emphasized. I mean, when we talk about the very simple act of drainage and how integral that is to not only the issue of landslides, but even flooding when it occurs, when we were speaking about the high intensity of these monsoon seasons.
Usually during the monsoon seasons, at the same time, we experience flooding, is that right? But at that particular time also, quite numbers of landslides happen, but then most of them on the natural slope, but all inside the jungle and so on. Nobody aware about this. Right. But JMG, we have captured that information just for the record purposes to understand why it's happening. Mm-hmm. When it's happening behind the house or close to the building, then it becomes the news. But we have also experienced a phase slope on the natural. When it comes to back to the mitigating measures just now, I would like to emphasize on non-physical method. I mean, non-physical means one of them is my favorite subject. Is we need to have a proper plannings of development on that particular area. For instance, if you want develop one particular area on the hill slope, we have a proper buffer zone, so that when any material fell down from the slope, then it won't affect very much.
So,
the building.
so a buffer zone is intended so that these areas won't be affected. But I guess when it comes to sort of the allocation of these properties, that buffer zone approach is not well received as much.
Oh yes, we receive a criticism, especially among the developers.
Yeah, I
about
imagine
the
that.
space.
Yeah.
That's why we have minimum space. So that's not only talking about the to reduce the risk, and also we need a space for in case of contingencies. For instance, if the slope need to be maintained regularly, then we need a space so that we can reach to that particular area to do a maintenance works. Just imagine if the house is close to the slope, bed to bed with the slope, then if there's any problem, it's very difficult for us to reach that particular area. That's one of the why we emphasize for the sufficient buffer zone for those very steep slope and so on.
So,
yes.
so I imagine that the developers will simply argue that they can actually improve the stabilization through physical methods, and therefore that will mitigate that particular issue, and rather than go with the non-physical method, right?
Yes, of course. We need a balance.
Right.
But then when we are talking about the buffer zone, they can design such a way. You know that when a developer want to develop a piece of land, let's say you have 10 acres, 30% of that 30% of that area should be a green area or facilities.
Mm-hmm.
That facility we try to design such a way so that facility just at the foot slope. Instead, we put a building close to the slope. That is also, I think they already anyway they have to surrender 30% of the area for that facility.
Mm-hmm.
For instance, we asking for 20 meters buffer zone. Within the 30 meters, it's not actually empty. It could be the road, access road, or the field.
There are various options that you can choose from.
Options they can choose. So it's not waste actually.
Mm-hmm.
Still within the, we can utilize that space for other purposes, to comply with the guideline and so on.
Okay.
So right.
So earlier on, you also mentioned about landslide mapping, but how can you use landslide mapping to reduce the risk of landscapes, and how detailed is our current landslide mapping?
For time being, in fact, in case in Selangor, we had done first scanning. We call it geological mapping. That's a first scanning. Let's say for you to understand, for instance, if you want to scan for the, we're talking about the medical profession. Let's say, if you want to know is it people have a cancer or not.
Mm-hmm.
First step, of course, you X-ray first.
Yep.
Then from that, you spot on some sign of a problem there, and then you go to the next step. Is of course we need another technology for instance scan through MRI or CT scan and so on. That's the advanced level. Then you can spot on. Geological mapping, the first level, then we need to do detailed assessment on that particular class 3 and class 4 area, so that we know within that area maybe certain place only which is susceptible to the landslide. Then we can focus on our managing the risk on that particular area. That's the purpose of that.
So we've only sort of done the scanning stage, and we haven't come to the second stage. Is that what you're saying?
We have done a selective area, especially those prone to, and also those residential area and so on. We have a very selective, but this program is a continuous program. You see that? Yes.
And you were talking about technology just now. So what kind of technology do we have and we aspire to use in terms of predicting landslides and reducing the risk?
We have many technology available right now. For instance, we can use remote sensing, or a LiDAR technology to pick up the terrain feature on that particular areas. And we have another technique, for instance, geophysical survey to probe what's underneath, to know what type of the material is, the loose or hard material and so on. That is a kind of technology available. But in terms of mitigating measures, we have a standard technology right now, for instance, using rock anchors, sonarings, and other methods.
Okay.
That's it, yes.
So as a layman, maybe wanting to buy a house or living near a slope, what
Yes.
sort of telltale? I mean, landslides don't happen overnight. It takes a while for a landslide to occur. So what sort of telltale signs should we look out for?
Based on the experience, perception, when we look at those face slope, I remember when I saw one of the case in Miri, Canada Hills. It take a few hours before the slope fill. First, they look at the bulgings of the slope. I mean, the bulging means the slope normally flat, and then all of a sudden it's bulge because something push up. And also tilting of the trees. And that's one of the signs. Another important is, of course, there's another stage, for instance, sign of crack on the land surface, or if there's structure there, there's a sign of crack. That means there's some kind of movement there. But the most important thing is because most of developed area, which we have drainage. So we should look at the drainage so that there's no. If there's a crack on the drainage, that shows that the drainage already moved. Then there's a one of the signs need to be looked at. Yes.
Dr. Zakaria, just to sort of wrap up the discussion on this matter, are there future policies that the Minerals and Geoscience Department is looking at in collaboration with other stakeholders so that we can sort of be more aware and improve the particular situation?
I think most important thing is the cooperation from all the agencies and also the developers. And I think even house buyers also need to play a role. If you have to buy a house, be selective and get the right information so that you study it and get the house. So that we want to make sure developer and also professionals do their job properly.
What information can the house buyer get from developers on that particular matter?
Oh, they can ask it, for instance, geotechnical report, geological report about that particular area. Then they may have friend, engineer and so on.
Or they can call you.
Oh yes, why not?
I imagine that technical report is not an easy read.
See, you want to know the interior design, you want to know if there's a swimming pool, but you want to know if there's a geological report. It's very important.
You can call me anytime.
All right. Thank you so much for being with us. Wrapping up the evening edition, Understanding Geology and Landslides. Dr. Zakaria, thank you for being in the studio.
I feel like I didn't fail the subject at school. I feel that much better about myself now.
Thank you very much.
Okay, stay tuned for Little Green Car, the John Wayne, BFM 89.9.
Thank you for listening to this podcast. To find more great interviews, go to bfm.my or find us on iTunes. BFM 89.9, the business station.